Okay, this is a recording for trigonometry and the angle of depression elevation. So trig is the study of triangle measurement. And what the calculator does is it actually stores relationships. So it actually relates sides and angles. Typically sides and angles aren't, knowing the side isn't going to help you figure out the angles total, but in trig it is. So the calculator stores relationships between any particular angle degree, opposite side of the hypotenuse. So if you look at an acute angle of a right triangle, let's say we're looking at angle A first. So angle A, acute angle A, this angle here, the ratio of the opposite side over the hypotenuse is going to be, opposite means it's across from A, and then hypotenuse is across from the 90. So the whole unit hypotenuse always is across from the 90. So from angle A, so from this angle, our sign would be whatever's on the opposite side, so A, over whatever's on the hypotenuse, which is C. If your angle of reference changes, so B is a different angle than A, so it's another acute angle in the triangle, but it's a different one, the opposite of this side is now B. So then from B, B is the opposite, and then the hypotenuse is still C. Okay, that's the sine ratio. Whatever's opposite of the angle of reference to the hypotenuse. Cosine is the ratio of the adjacent leg. So this is a leg next to the angle. So not the hypotenuse, because it's a leg. So remember, the two legs on the triangle are A and B, the little A and B. So the adjacent leg is the leg next to angle A. So in this case, we're looking at angle A as the reference. The leg next to that would be side B, and the hypotenuse is still C. If we're looking at B as our reference angle, the side next to that is A, that's the adjacent side, and then the hypotenuse is C. And then tangent is the ratio of the leg opposite to the leg adjacent. So we're talking about these legs. So looking from angle A as the reference, opposite would be A, little a, and then adjacent would be B. And then from B, opposite would be B, and adjacent would be A. So the acronym that we use to remember this is SOHCAHTOA, and it's just the first letter of each of the trig ratios and then their actual ratios. So sine is opposite over hypotenuse, so we use SOH, the first letter of each of those. Cosine is adjacent over hypotenuse, so we use CAH, and then tangent opposite over adjacent. So we just write this here. I'll write them really quickly. You can pause it, write it down. Okay, so you can pause it and write those in. Sorry, I got a text. Okay, so for number 1, we're going to give each trigonometric ratio as a fraction in simplest form, so we want to reduce it if we can. So from angle A, we want the ratio of whatever's on the opposite of that side, of that angle, and the hypotenuse. So from angle A, if this is my reference, opposite with that would be 5, and the hypotenuse of the triangle is across from the 90, so that'd be 13. For cosine, we want the adjacent side to the hypotenuse. So the side adjacent, remember, is one of the two legs, so it's one of these two, and it's the leg closest to A, so 12, over the hypotenuse. And then opposite, we already did, was 5 over the adjacent, which was 12. If you change and go from C, then your opposite and adjacent side changes. So from C, the 12 is opposite, and the 5 is adjacent. So then tangent, which is opposite over adjacent, is going to be opposite 12 over 5, which is adjacent. Okay, so 2 and 3 are doing the same thing, but you have extra one step because they've only given you two sides, the two legs. They haven't given you the hypotenuse. So we want to go back to review Pythagorean theorem, which we did earlier in this unit, and solve for wx, which is across from the 90, so that's the C of the Pythagorean theorem. So you would solve the Pythagorean theorem here, and you should have mastered that by now, so I'll let you do that. And then on this problem, you're also going to have to solve for Km, and it's B or A, because C is 34. So 16 can be A, and then B can be unknown. So if we solve this out, this side is 15. I'm doing the bottom one now. Square root of this 30, so B is 30 for this one. Okay, so now we can do from W, the opposite of this. So if I just do W first, this is opposite hypotenuse, because it's across from the 90, and then adjacent. So sine, which is opposite over hypotenuse, is going to be 12 over 15 for my ratio. 12 and 15 are both divisible by 3. So 12 divided by 3, I'll get 4, and then 15 divided by 3, I'll get 5. So my answer really is 4/5 in simplest form. Okay, from W, I want A over H, so adjacent over hypotenuse. So 9 over 15. Those are both divisible by 3 again, so 3/5. And then from tangent, I want opposite over adjacent, so O over A, which is 12 over 9. Okay, if you're going from X, then I'm doing it in pencil, so it's a different color. This is now O, and this is A. But H is still 15. That doesn't change. So really what happens is the cosine, which was the adjacent and the hypotenuse before, comes opposite in the hypotenuse now. So these two are going to be the same, and these two will be the same. And then this flips because opposite and adjacent flipped. Okay, so go ahead and try those, pause it, and I'll put the answers up. Okay, and then you can try 3 on your own. All right, then the process for solving for sides using trig, and not just writing the ratios, is we have really 4 steps. I'm not going to rewrite these steps out, so I'm going to project them if you want to write them. I did write them in all the classes, so if you want to pause the video and look at the steps here, you can write these out. So you can pause the video and write the steps out if you don't have the steps already written out. But I'm going to save myself a little bit of time and not do that part, since this is just a tutorial video, and you can pause the other screen. So to solve for X, hey, right, no, I'm just okay, so for the step 1, which you just saw on the previous screen, and you can rewind it if you need to copy it on your paper. It's probably a good idea if you don't have it already on your paper to copy it, is to pick an acute reference angle. So there's 2 acute angles in the triangle. It's going to be this angle and this angle are both less than 90. You need to pick one of the acute ones. And I say pick one angle, it's because sometimes they give you both of these. So in order to not confuse yourself, you want to circle one. In all of these problems I give you, only one of them is numbered. So we want to use the numbered one, so we don't have to do any extra work to calculate what this angle was going to be. So we would pick our acute reference angle. Then from there we want to label the sides as opposite. O stands for opposite, hypotenuse, and adjacent that have something on them. So we don't care about this side because it doesn't have any number or variable on it. But we want to label from the 28 what side this is and what side this is. So from the 28, this is across from it, so this would be opposite. And then this is opposite the 90, so this is H. Then we will come to our formula sheet. Step 3 is to pick a trig equation. So this formula sheet is going to be provided for you on the EOC and on any class test. We're going to look to see which of the formulas uses opposite and hypotenuse, because we want to use that equation. So we have 3 different choices. The one that uses opposite and hypotenuse is the first one, so we're going to use sine from angle A. In this case, the 28-degree angle is equal to opposite over hypotenuse. So this is the exact equation that we're using. We're substituting in things that were from the picture. So the angle in our case is 28. The opposite is x, and the hypotenuse is 19. So a lot of students want to skip here to start putting things in your calculator, but it's probably a good idea to solve all the way for x. So the last step is to set up and solve, and when I say solve, it's solve for x. So you want to get x by itself before you plug into the calculator. So I'll do this in pencil to show that this was in red is our original equation. I'm now solving to get x alone. Right now, x is divided by 19. The inverse operation of division would be to multiply both sides by 19, which cancels it on this side, because you have 19x. Really, this would turn into 19x over 19, which 19 over 19 is just x. So you have x equals 19 sine 28. So once x is on a side by itself, then you can go to the calculator. So to type this in on the class calculators, you're going to type in 19 times, and then you have to tell the calculator what you're taking the sine, cosine, or tangent of before you do it. So I'm telling it, hey, 28 is the number I want to take the sine of. And then that's just telling me what the sine of 28 is, but I need to hit equals to get the final answer as 8.9. Okay, so again, what you're going to type in, if you're on one of the class calculators, is 19 times 28 sine, and then equals. You do have to hit the equals button, or else it's just going to tell you what 28 sine is. Okay, and that's our process. So if I do number 5, we have a reference angle of 41. That's an acute angle. So this side is across from it, so it would be labeled O. This side is next to it, and it's a leg, so it would be labeled A. Then I would come over to my sheet and see which of these equations uses O and A. Tan. So tan from the angle is equal to the opposite, whatever's on that side, over the adjacent. So tan from 41 equals x over 32. And you multiply both sides by 32 to get rid of this, so it's 32 times 41 tan equals 27.8. So that's the process for these. When you get down to number 8 and 9, it's still the same process. So OH, you can pause it and do this process on your own. So this is going to be sine 33 equals 2. Okay, when you get this, because before x was in the numerator both times, so we just had to multiply both sides, and x was already isolated. Since x is in the denominator this time, when we multiply both sides by the denominator, we don't actually have x solved for yet. We have x sine 33 equals 15. Then we want to get x by itself, so we have to divide both sides by sine 33. So the 33 travels with the sine, and then you're left with x equals 15 divided by, in this case, sine 33. So everything is the same, except for instead of pressing times, you press divided by. So this is 27.5. So again, if you end up with the number on the numerator over a variable with a trig ratio, then you're going to divide. If you end up with a variable over the number, then you're going to multiply. But you can, if you understand algebra, you can get to that every time. Okay, then the word problems, a couple of hints for these. So we're looking at creating a triangle if possible, because we can only solve these trig problems in this whole unit really with the right triangles. So things like leaned a ladder means we're going to have a side like this. So he leans a 12-foot ladder up against the side of a house. If the angle formed by the ladder and the ground, so this is the ladder, this is the ground, that means that this is the angle that's formed by the ladder and the ground. So the two sides of the angle with the ladder and the ground would be 68 degrees. How far from the base of the house did he place the ladder? So you don't place ladders up here, that's just where they fall once you place the bottom. So this is the side we're looking for, because we want to know how far from the bottom of the house, the base, every time we see base, it's bottom, did he place the ladder. So we're doing trig, but we have these two sides as the two sides we're looking for, no. So from the 68, this leg is next to the 68, so it's adjacent, and this is the hypotenuse. So we're going to use A and H, which is cosine. And because the 12 is down here, when we multiply both sides, x is solved. So when 12 is on the bottom, we're good. X is solved in one step by just multiplying. And the answer is 4.5. Okay, so a couple more word problems for you to try, and the answer keys are provided. Key is provided. So if you're doing the back now, finding the measures of the angles, we're starting off the same way, but in the end, we're going to use these negative ones on the calculator. So on the calculator in green, there's these inverse, they're called inverse trig equations, which is where you have to hit second, and then that gives you the answer. So setting this up, same way. This is opposite and hypotenuse. So sine x, because that's my angle, equals opposite over hypotenuse. So I would do 15 divided by 24 equals, and then I want to hit second sine. Okay, so sorry, I went through that quickly. So 15 divided by 24, that's going to give me a number. And when you're looking for angles, you're going to get the value for the fraction, because both parts of the fraction should be provided in the problem. And then you just have to hit second sine, which gives you the -1, and that will do the inverse for you. So 15 divided by 24, figure out what that equals, and then hit second sine. Okay, it's not always going to be sine, it could be tangent, cosine, or whatever. So, but that's the process. So if we do another one, we have O and, that's a leg, these are both legs, so these are O and A. And then A is the leg next to the angle, O is the leg across from it. So this is going to be tan x equals 20 over 37. So 20 divided by 37 equals 54, and then I would hit second tan, because we did tangent. So 28.4 actually. Okay, and then there's some mixed review for all of that. For you to practice. So try a couple of those with the key. You should be good. And then the angle of elevation depression is more trig, but you just set up the problem. Basically, it's like the word problems for trig. So angle of elevation, if you want to read this, when looking up to an object, so your line of sight is normally just horizontal. If you look up to an object, then you're elevating your eyes, so it's called an angle of elevation. So if we do a problem, an example of that, Casey sights the top of an 80-foot tall lighthouse, 84-foot tall lighthouse at an angle of elevation of 58 degrees. So he's standing here. He's looking up at the top of this lighthouse. It's 84 feet. If he's a 6-footer, how far is he standing from the base of the lighthouse? So all of these words in here are kind of key. The base of the lighthouse. So how far is he standing from the base of the lighthouse? So him to the lighthouse would be x. Something that's tall is going to be usually a vertical length. 80-foot tall is straight up. And then angle of elevation we just talked about is if him lifting his eyes from straight to an object above him. Okay, and then we're going to do trig. But because he's 6 feet, his eyes start kind of close to the top of his head. This is going to be 6 feet. So really we need to use not 84, but 84 minus 6, because 6 of the feet, his eyes didn't have to elevate to. He was already above that level. So 78 is what we're going to use, but we're still doing trig. Okay, so from the angle we have O and A, so it would be tangent. It's O over A. So because x is on the denominator, we multiply it both sides. X isn't quite solved, so we need to divide by tan 58. Okay, it's Friday at like almost 3, so that's why I'm going a little quickly through this, but you can pause this and kind of go ahead of me and then just come back and check to make sure you're doing these right, but 48.7 would be the answer for that. Okay, so the process is it's the same once you set it up. It's the trig problem. So you're actually just continually practicing trig, but it's this is kind of helping you with comprehension to make sure you understand what different words are keying you to. So the angle of elevation from a kicker's foot, so the foot of a kicker, so we got something like this. The angle of elevation is 17 degrees. If he is standing 131 feet from the base of a goalpost, so he's standing from the base of a goalpost, the bottom of a goalpost, 131 feet away. How tall, so this is vertical distance, is the goalpost. So again, I'll let you do the trig because you should be good at that by now, but that's just the setup. So you're looking for keywords like bottom or vertical height, and then if it says like something like a slide, you would be using this, or if the ladder's leaning, you would be using this. So things like that. Okay, on the angle of depression, it's very similar. So you're just basically starting at a height above where you're looking. So if you're starting here and then you're looking down at something, then the angle is depressed. The angle of depression is actually the same, it's congruent to the angle of elevation because they're alternate interior. So alternate interior angles are only congruent when lines are parallel, but the ground is parallel to a horizontal line of sight, so these would be equal. So the angle of depression is really the angle of elevation here. Okay, so lifeguard sitting on a platform looking down at a swimmer in the water. So this is really the same scenario as up here. Okay. If the lifeguard's line of sight is 8 feet above the ground, so he's really only 8 feet above the ground. So above the ground, again, means we're talking vertical distance. And the angle of depression, so his line of sight is here. Normally, he has to depress his eyes 18 degrees to look at the swimmer. So it's not here because he's not looking down naturally. He's looking straight ahead. And then looking 18, he's depressing his eyes only 18 degrees. So how far away is the swimmer from the lifeguard? So the swimmer's here, swimmer's here, lifeguard's here, so we're looking for X here. Well, 18 is not in the triangle, so we want to put it in its alternate interior spot so that we can use trig now with these two sides in this angle. So we have O and H, and then from this angle we have O, opposite side, and H, which is hypotenuse, so you can do your trig. So this is going to be one where we divide because the number was on the numerator. So it would be 8 divided by 18 sine equals, so about 25.9. Okay. Alright, so practice these, try what you can. The test is next class. If you're in a B-Day class, I see you Monday. The test will be Monday. If you're in an A-Day class, then if you don't understand something, then you can come after school for tutoring. Otherwise, check the web. There's a bunch of videos on all these topics and stuff. So just look at the topic titles, and if one of these didn't make sense, you can reference one of those. Good luck.